So this one we'll need a calculator for. To the nearest hundredth, that's sort of the hint that you're going to need your calculator. Solve the equation cos x minus 6 equals 4 cos x minus 4. And the range they give us is from negative pi over 2 to 3 pi over 2. Then write the general solution. So again, we're going to start by solving this just between 0 and 2 pi. Then we'll write the answers according to the domain that's given, and then we'll write our general solution. So if I combine my like terms by adding 6 to both sides and subtracting the 4x from both sides, can you see that you'll get negative 3 cos x equals 2? Dividing both sides by the negative 3, getting cos by itself, you get cos x equals negative 2/3. If you draw a picture of this, because cos is negative, you know it ends in quadrants 2 or 3. And so if you drew a picture of a reference angle in quadrant 2 or a reference angle in quadrant 3, you would know that the adjacent side is 2 and the hypotenuse is 3. And if you wanted to solve for that reference angle, you could just use your knowledge about triangles. And our reference angle, I guess it should be an x, not a theta. Our reference angle for x will be cos inverse of positive 2/3. So this is where we're going to need our calculator. The question's in radians, so we make sure our calculator's mode is in radians. And cos inverse of 2/3 gives us a reference angle of 0.841. So now to find our angles, the one in quadrant 2 will be pi minus our reference angle. To the nearest hundredth will be 2.30, and the other one will be pi plus our reference angle. I guess since we're approximating, should use the approximation sign. And so there are our two answers between 0 and 2 pi. Okay? But now we want to go back and check the domain that's given to us. The domain that they've given to us is, they say, negative pi over 2 to 3 pi over 2. So I always sort of start with 0. And if I think about my negative values, can you see the only negative values you're going to have are from 0 to negative pi over 2? That's looking right here. Will we have any answers in quadrant 4? No. So that's not going to affect our solution. If we think of our positive values now we're going from 0 to 3 pi over 2. That would start here and go all the way up to here. How many answers would that hit? That would hit this one and this one, right? Which we've already got. So our solution doesn't change because of the domain. Sometimes it will, but in this case, the fact that they changed the domain didn't actually change our answers. So those are the answers between negative pi over 2 and 3 pi over 2. If we wanted to write our general solution for this one, we've got 2.30, add 2k pi, 3.98, where k is an integer. So that gives every single coterminal angle with those two. And that's what makes it a general solution. Part B. Is everybody done with part A? Should I go back? Go back or good? Good? All right. So here's our next one, part B. We've got root 2 cosecant x equals negative 5 for negative 180 to 180. So now we'll have to go to our calculators and switch our mode to degrees. Because our domain is in degrees, We know it's a calculator question. If I get cosecant by itself, I'm going to get negative 5 over the square root of 2. Now, you don't have a cosecant button on your calculator, but the reciprocal of cosecant is sine. So if cosecant of x is negative 5 over root 2, sine of x will be negative 2 over root 5. Sine is negative. Where does that happen? Third quadrant. So this would be our reference angle, or the fourth quadrant. So this would be our reference angle. Sine is opposite over hypotenuse, so you know your hypotenuse is 5. The opposite side is 2. And given that triangle, you could find out what that reference angle would be. That reference angle would be sine inverse of 2 over root 5. So notice every time we're finding a reference angle, we're always using positive values because we're thinking about the actual triangles with actual lengths, and all those lengths would be positive. Go to our calculator. Again, make sure you've already switched your mode from radians to degrees. And when we do sine inverse of 2 over root 5, we get a reference angle of 63.4 degrees. So then our angles that we're going to find, if we're doing between 0 and 360 to start, you'd have to do 180 plus the 63.4. Rounded to the nearest degree would be 243 degrees. And 360 minus our 63 degrees, rounded to the nearest degree, is 297. So those are our answers between 0 and 2 pi. Now we're going to go back and look at the domain that they're asking. What negative angles are they hitting? From 0 to 180. So if I think about starting at 0 and going to minus 180, how many of these angles would I hit? Both of them. What would those angles be? Because this answer and this answer are not in our domain now, because they're past 180. So we have to say, well, what is this first answer going to be? Well, our reference angle is 63, so it's going to be negative 63. And what's this second one going to be? Negative 117 degrees, because it's 180 minus 63. And our positive direction from 0 to 180, would we hit any angles if we did the positive 0 to 180? No, because our answers are only in quadrant 3 and quadrant 4. So those are our two answers. Our general solution then. Well, for our general solution, we write all the answers between 0 and 360. We found out there was 243 and 297. Add k times 360 degrees, where k is an integer. Questions 6 and 7 are ones that you can practice with this.